Right. So now here we have the concepts of work and energy and power. We're going to learn on how to define work, energy, and power. Calculate the form of energy by using formula kinetic energy and potential energy. State the principle of conservation of energy. Describe conversion from one form to the other. Apply the concept and formula of work, energy, and power in solving the related problems. Calculate the efficiency of mechanical system. But this one, efficiency, I'm going to take it out. Okay. These are the objectives of the whole topic of what it is expected from you to understand. Right. Did you know how many steps of Batu Cave stairs? That's the question. Question number 2, what is the height of the stairs? You will answer that. How to measure our work or energy when climb a stair? And who has the bigger power to deliver up the stair? Those questions. Make sure that you answer them at your own convenient time. Right. Without wasting any time, let us get to the concept. Now, what is work? Work is such a big word, right? I think all of you are familiar with this term work. I'm going to work tomorrow. I'm not going to work tomorrow. We associate work with things that we do as activities, right? For daily routines. But now here, because we are doing physics, we need to define work based on force and a displacement, okay? For an example, what you see here on this picture right here, we have a trolley, right? When you apply a force on a trolley for a certain displacement, when you change the position, look at the initial position of the trolley, and then you apply a force to a trolley, and then it attains a certain displacement. Now, in this case, we can say we have applied a work on this trolley. Now, work it is actually defined as the product of the force and the displacement of an object in the direction of the force. Now, if we want to calculate work mathematically, the formula that we use is this one that is denoted by W is equals to F multiplied by S. In this case, F, it is a force that is parallel to the displacement of the moving object. In this case, look at the trolley, look at the force. The force is moving to the right. The displacement, it is also pointing to the right. Having a look at the force and the displacement, they are parallel to one another. So that means in this case, we can just say the angle between the force and the displacement is going to be 0 degrees. Now, what do I mean when I say that? Normally, when we calculate work, we use a formula. W is equals to force applied multiplied by change in X most of the time. I don't know what happened there. Let me just erase. We say work is equals to force applied multiplied by change in X. In this case, change in X represent S, which is the displacement in meters, multiplied by cos theta. Generally, this is a formula that we use to actually calculate work. Now, in this case, theta, it is the angle between the force and the displacement. Now, if you want to learn on how to determine the direction of the force and the displacement, I would highly advise you to use the direction of a compass. We know that a compass, it is something that looks like this. Not a compass per se, a protractor. It's something that looks like this. Excuse my drawing. And we know that here we have 90 degrees, which acts perpendicular to this line of reference over here. And then in this direction, which is in this direction, is going to be 0 degrees. And in this direction, we're going to have 180 degrees. Now look at the force, look at the displacement. Displacement is a vector quantity. It has magnitude and the direction. It's not a distance, it's a displacement. Now this trolley moves a displacement to the right and the force is to the right. And we take to the right to be in this direction. We take to the left to be in this side of the direction. Now a theta, like I said, a theta is an angle between force and the displacement. Look at the theta. The displacement, it is in 0 degrees, and the force applied, it is also in 0 degrees, meaning they act parallel to one another. So when you punch cos 0 degrees on your calculator, you're going to get 1. Hence why this formula over here. So this S, you can also denote it as change in X. So that's how we calculate a force that acts parallel to the displacement when we want to determine its work. And then the units that we use to calculate the work is joules, because work, it also refers to energy. So this is how we define work, and this is how we need to understand work. Work is due to force applied and a displacement at which the object will be moving at. That's how we define work. Now, let's have a look at this picture. We say that energy, it is actually defined as capacity to do work or ability to do work. That's how we define energy. And the SI units for energy, it's the same as joules. And you need to understand that we have many different types of energies. They come in many different forms, and they can be converted in certain forms to another forms. So one of the most common examples of energies that we know of, we know that we have the kinetic energy, we have potential energy. Under potential energy, we can also have gravitational potential energy, okay? We have the electrical energy, chemical energy, solar energy, and nuclear energy. There are many different types or different kinds of forms of energy. Remember, these forms of energy can be converted from one form to the other form. For an example, electrical energy can be converted into a light energy by a bulb. Okay? So this unit, it is more on energy. Right. Now let's talk about power. What I did on this slide is a quick summary. What is happening on this slide is all about the summary, and and then we'll do the questions. Now let's talk about the power. Now, how do we define power? We say power is ability to do work. Another definition that we use, which makes sense more than this, we say that power, it is the rate at which work is done. Okay? We say power, it is the rate at which work is done. This is how, for your curriculum, this is how you define power. They can ask you an exam, define what is power. This is how we define power. Now, the formula that we use to calculate power mathematically, it is given over here, where we use work and time. So having a look at this definition that I have just gave to you, I said that the power, it is the rate at which work is done. Rate simply refers to time, and then work simply refers to energy. The rate at which energy is done, the rate at which work is done. You can also define it in two different ways. Now remember, at first, we spoke about a trolley, right? And now this trolley attained a motion by moving from a certain point to the other point. What we did is we applied a work on that trolley. How did we apply a work on that trolley? By applying a force for a certain displacement. Therefore, work was applied on this trolley. Now let's talk about the power that is acting on the trolley, the power of the trolley. So when we apply a work on a trolley, there is a specific time that we use to apply that work, or a specific time that a trolley is actually in working. So that means if we have a work and then we take a time at which the work is being applied on the trolley, we refer to that as power. Now, the units that we use for power, we use watts, which is denoted by letter W. If you are given in kilowatts, we convert them into watts. If you are given megawatts, we convert them into watts. Kilo means 1,000, mega means, I think, 100,000, something like that. So now, this is a formula that we use to calculate power. Now, this is what is happening once more again. We said that power, it is actually equals to work divided by time. But we know how to calculate work, right? We say that work, it is actually force. What's happening with my pen? We said that actually, we said that a power is equals to force, mean work. Work is equals to force multiplied by the displacement divided by time, right? But now, having a look at displacement and time, which is meters per second. Remember, displacement, it is in meters, time, it is in seconds. So when you divide the displacement with time, what do we get? We get indeed the velocity. So that means power it could be the same as force multiplied by multiplied by velocity. Now the power of body, strong and fast. So now let's have a look at this guy over here. The force that is going to apply and the velocity that is going to use to apply that force, it refers to the power of individual. So you can also calculate your power using this formula, which says power is the same as force multiplied by the velocity. So far, a quick recap. What have we spoke about? We spoke about work, we spoke about energies, types of energies, and then we spoke about power. Now let's twist a little bit where we're gonna talk about these two types of energies, the kinetic and potential energy. When you talk about the kinetic energy, I believe someone right there wants to scream out and say, I know what is kinetic energy. Kinetic energy is a type of energy an object possesses when it is in motion. For an example, wherever you are right now, if you decide to move from that position to another position, a type of energy that you're going to possess is called the kinetic energy. Now, let's talk about the potential energy. Potential energy, it is actually a stored energy. But under this concept, we are not actually going to talk about the potential energy as it is, but we are going to talk about a specific potential energy, which is called the gravitational potential energy. Now, when you talk about the gravitational potential energy, it's an energy that an object possesses while it is kept a certain height above the ground or above the Earth's surface. When you pick up a box from a ground, we know that a box, it is suspended in air because of your hands. But we need to take into consideration that there is a force of gravity that is trying to pull that box down to the ground. But because there is an energy that is holding that box in a fixed position which is above the ground, that type of energy, we're going to call it the gravitational potential energy. Okay? I love this topic. Now, let us do a quick recap on kinetic energy. Look at this car, and if maybe the sound it is audible, you will hear the vroom sound of the car. Ah, what happened? A car moved from this point to that point. It moved down the slope. Now, for the fact that this car is moving, it possesses what type of energy? It possesses a kinetic energy, whereby the kinetic energy is energy due to the motion. Now, mathematically, as physicists, this is what we do. When we want to calculate the kinetic energy, we use the equation that says the kinetic energy is equals to 1 over 2 multiplied by mass multiplied by velocity squared. We know that. And then the units that we use, kinetic energy is energy. All of the units that we use for energies, we use joules. Okay? So this object, it has mass, it has velocity, we can calculate its kinetic energy moving down the slope. And have a look that the units for mass, we use kilograms, and then the units for velocities, we use meters per second. Now, again, we have a car of mass 624 kilograms, and then it is moving down the slope with a velocity of 150 kilograms per hours. This is negative. We do not use these units. We use meters per second. We don't want kilometers. We don't want hours. So each and every time when your parameters are given in unwanted units, we convert them into the desired units. Now let's read the statement. They say to us, a 624 kilogram of F1 car is moving at a speed of 150 kilometer per hour. Determine the kinetic energy of the car. Let's move the car down the slope. Oh, it really moved with that velocity. But now, how are we going to calculate its kinetic energy? It's simple. The formula that we use to calculate the kinetic energy, it is denoted over here. We need mass and velocity. So our mass, it is in kilograms, correct units. But the speed needs to be converted first. So remember, 1 kilometer corresponds with 1,000 meters. Kilo means 1,000, okay? So that means we're just gonna say 1 kilometer multiplied by 1,000 meters divided by 1 kilometer so that the kilometer can cancel the kilometer. And therefore, 1 hour is equals to 3,600 seconds. We also do the conversion over there. And then we multiply all the numerical values. And then we get that our speed will be 41,67 meter per second. We substitute the velocity and the mass on the equation, and then we get our energy in joules. So that means 1 joule corresponds with how much? It corresponds with kilogram meter squared per second squared. Okay, that's what 1 kilo, I don't know what's happening with my pen right now. That's what 1 joule actually corresponds with. Okay, right. This is a question and answer. That was a kid. That was absolutely a kid. Now let's talk about the